Hi, this is Margo. This is Sunday afternoon, August the 9th, 2020. I hope everyone is doing as well as possible. I can't believe how fast these weeks are going by. It's just one right after another, and so much happens in one day. It's like we live a whole lifetime in one day. So, I have methane data from Saturday, the 8th, and for CAMS and also for NOAA. This is my weekly update that I'll put on YouTube. We're going to look at climate Reanalyzer and the Arctic sea ice and some earthquakes and just do a little roundup here. So I'm going to start with the methane data from NOAA that I'm now tracking on a daily basis, and this is from the 477/469 millibar reading. This is for the Met-1 satellite from yesterday, from the morning. The mean was 1906 parts per billion, and the high reading was 2377. Now this mean or average, that's the highest we've seen it so far, and that's getting up there. And then when you go to the Met-1 satellite in the afternoon, now the mean is 1907. Now that's the highest that we've seen it. So we're setting records all the time, and the high reading was 2337. On the Met-2 satellite in the morning, the mean was 1886, the high reading was 2482. And in the afternoon, the mean was 1884, and the high reading was 2404. So here's the spreadsheet and chart that I've been posting to since March of 2019, just to kind of do my own research here. And here it is for yesterday, the 8th. Up here are the numbers I called off just now, added up and divided by 4, so we come up with an average for yesterday of 1895.75 parts per billion, showing an increase from last Saturday, the 1st, of 4 parts per billion this week. So that's a very sharp increase, and it's 2 weeks in a row that we've seen 4 parts per billion. So here's the graph here. We can see it's going up, and here it was in March the 1st of 2019. And this is what it's been doing. Here was where it was at its highest last year in October of 2019. And that was 1885.75. Now traditionally, methane rises starting about in June or July, and then goes up through about mid-October, and then it's supposed to go down. And what's been happening is that when it goes down, it doesn't go down to where it started, and so we're at a higher starting point every year. And it's been going up earlier and earlier in the year. Like this year, it started going up in February. We had a sharp increase from February till I think at the end of March, and so going into the heating time, we were already at a much higher level. We were already almost at our high point from last year. So we can see a change from this year, from since it's started over a year on February 29th. We've seen an increase of 19.25 parts per billion since then. Since March the 1st of last year, we've seen an increase of 38.50 parts per billion. Now, over here is where I'm tracking it on a daily basis, and I'm reporting on it on my Subscribe Start page for those who would like to have a little more in-depth and more often reporting. I'm reporting on almost daily basis over there for my members and posting, and I really like the community. It's small, but there are no trolls because it's a subscription community. It's kind of like Patreon, but you know, once you join up, you get an email every time I post. We can private message back and forth. You can leave comments under the videos, and it's just I really like it, and there's some really great people over there. So there's that. So here's what we saw this week. So here it was on Saturday the 1st at 1891.75, and that was an increase from the day before, 1.25, and that's where we saw the weekly change of, you know, an increase of 4 parts per billion. Then on Sunday it was 1892, so that was a little increase of 0.25. Then on Monday we saw a steep increase of 1.25. On Tuesday we saw a steep increase of 1.5. On Wednesday we saw a decrease of 1 part per billion. On Thursday there was no change. On Friday we saw a slight increase of 0.25 parts per billion. And then on Saturday we saw a very sharp increase of 1.75 parts per billion, which gives us a rise since Saturday the 1st in 1 week of 4 parts per billion again. So February the 8th was where we started really zipping back up this year, and since then we've seen an increase of 32.5 parts per billion since February. And February the 8th was where we started, it started increasing that week. And like here, the week of that ended on March the 28th, we saw an increase of 4.75, and then the week that ended June the 6th, we saw an increase of 4.25. And you know, we've had some ups and downs. Here's another week of increase that ended on July 11th, an increase of 4.5 that week. And now the last 2 weeks we've seen an increase of 4 parts per billion. So that's on the rise now. Now let's look at the CAMS data. Their latest data is for yesterday, the 8th. I have the Arctic pulled up and surface level. So this is for the same day as that we just saw that increase of 1.75, or what was it? Yeah, 1.75 in one day. So here's where it left off on Friday with this high release here in the Kara Sea, And you can see the higher background colors reaching into the lighter greens and yellows and oranges. We're also seeing this higher reading here over this East Siberia Sea, and you're going to see waves of green coming up here in lighter green. So let's just run the movie and then we'll see what we can see. So we've got the Scandinavian area just totally covered in methane. You can see it kind of moving out and dissipating down in this Barents Sea. And then it starts pulsating up, and it's usually by Tuesday or Wednesday of the week we start seeing another high release here by Severnae Zemlya. We're seeing these higher readings here in this East Siberia Sea. Now this is where the East Siberia Arctic shelf is located, just under the surface in the sediment, where Natalia Shukova has done her research and found huge methane stores there. And Sam Carana has a map of methane, where they think these huge methane deposits are all the way through the Arctic. So it's not just in this East Siberia Sea, it's all the way through and all the way up and down the Baffin Bay here to the west of Greenland. So anywhere that you have these open waters with the sea ice melting and the open waters, so that the radiation from the sun and the heat from the sun is now being absorbed in the water rather than being reflected by the sea ice, then the waters are heating up, and then that's causing the seafloor to heat up and the sediments to heat up and these clathrates to start melting. And then we've seen high readings all the way across Russia, because they've been having high temperatures here and the permafrost is melting, and so as that's melting it's releasing carbon and methane as well. And we've got a lot of wildfires in Siberia still, and that's releasing a lot of methane and sulfur dioxide and noxious gases. And we also have a lot of methane from the southern part of Alaska up through the interior, and they have a lot of melting permafrost as well, and a lot of earthquakes and volcanic activity, and so all of that will release high levels of methane. We still have this problem spot here in the North Atlantic off this northeast coast of Canada. So the data is for Saturday, and the forecast runs Sunday through Wednesday. We're seeing these high readings all across Canada as well, and from the middle of the United States over eastward, and this eastern seaboard on the U.S. is very high. Here's the North Pole view. We can see pretty much the whole northern hemisphere from this view. That's why I like this one. So we can see Europe filling back up with methane, and Ireland and the UK filling back up. Here's the Persian Gulf. Here's India. This whole northern ridge is filled, and also north of India's filling up. Here's China. Here's this eastern seaboard on the US. It's high readings here. Florida, high readings down there. High readings throughout a lot of California, especially Southern California there. Now we'll look at the global view. Now what we're seeing, I've been seeing this for the last week or so, is that these light blue colors are migrating further south. We haven't seen readings this high, this far south, and so this means that worldwide that the readings are getting higher. And so we're seeing it reflected in the colors going from the blue to the dark blue right here, which is about, what is that, 1800 parts per billion, this dark blue, to the next lighter blue, which is 1820, which is this color. And then the next aqua blue-green, which is this, like this color, you can see it. That's about 1860 and so forth. And then by the time you're really getting into the greens, it's 1900 and above. Now remember, this is surface level here, which is within below 1,000 millibars. And as you go up in the atmosphere, the millibars, the numbers get smaller because it's sea level pressure, or HPA. We're also seeing releases coming up through the sea ice in the Antarctic, all around the coastline. We can see it all the way around. And it's still dark down there. The Earth is started tilting. The North Pole is started to tilt away from the sun, and the South Pole is starting to tilt back towards the sun. But we're not seeing a huge change yet. But we will. Here's 500 HPA. I will refresh so that we can see the right color ledger. So the heaviest concentration is over northern India. Then we see it red going across to China. There's a high reading up here in Siberia. This is from the wildfires and permafrost melting. Then there's a high reading up here in the northern United States and Canada there. But if we ran the movie, you'd see the cloud moving across. We're seeing much higher light greens, and look at these lighter greens now moving further south, and the yellows are migrating further south too. Used to be we would see the cutoff line about the equator where the green was, and then this would be more blue in the southern hemisphere. But this is as a result of total global increase of methane. We see it increase all around the globe, not just in one place. Here's total column. Oh, let me refresh so we can get the correct color ledger. So this top end is between 1920 and 2320 parts per billion. That darkest area, we see that over here over China and a little bit over India. Then we see the bright red and the next darker red, so that's 1880 to 1920, these red areas. So this is about halfway up in the atmosphere, about the same as what we saw on the NOAA. And then you see like these red-orange, this red-orange color. That's 1860 to 1880 parts per billion. And as methane keeps going up, then these red-orange areas will turn red. That'll be the next areas to turn red. We're also see the green down here all the way to the south, the Antarctic, all the way down to the continent there, and here over the Ross Sea. So like I said before, it's all going up, and so you'll see changes. And if you go back through some of my older videos, especially through the archives on my Subscribe Star archives on my website, you can just look at the pictures, the title page of the daily reports I do where I show methane, and you can see the changes in the colors. So it's happening. This is all happening very fast. Okay, let's continue with the slideshow. Okay, here, this is the dust cloud from Africa. It keeps coming across the Atlantic, and here's one that's going over the Caribbean now. Here's the next one coming across, and look at all this dust. It's coming out into the Arabian Sea and over Saudi Arabia and going up over India and Pakistan and so forth. So they've got huge dust problems over there. Now this is the Arctic view. This is the smoke from the Siberia wildfires. Now these are from CAMS, these pictures. All of this, and it's spread out over this North Pacific. Here's the North Pole view, and this is sulfate aerosol. This is from the sulfur dioxide event that we're having in the Pacific. This is from the Nishinoshima volcano still erupting, one of the Japanese islands here in the Pacific. It's been erupting since June the 19th. This picture is total aerosols for the planet. This includes dust, sea salt, wildfires or smoke, and sulfate, all the stuff that we breathe in. So some areas you'd have a real hard time breathing. You would need to wear a respirator just to breathe the air. Okay, I've been following this ozone hole over the Arctic, and it's getting bigger, and then it's this is a thinner right here. We can see this aqua color here, and the green is thin and or chartreuse. So this is from the wildfires, I'm thinking, that have been going off for so long over Siberia, because that smoke just gets caught up in the jet stream and everything. And so as this hole or the ozone layer is so thin up here and the sun's beating through, then of course the open water and the sea ice is absorbing that radiation, and then it's making the sea ice melt faster as well, and it's also heating up the water faster. Here's the global view of the ozone. Now there's a hole quite thin opening up here in the Antarctic. And we can see it's thin all around the equator, and these greens are thinnings, so it's not looking good. Here's the South Pole, and so here's part of the ozone hole here in the South Pacific. Here's another one here over the western side, and most of the continent is at least in the chartreuse and under, and then this bluish purple, this is down to 200 Dobson units, which NASA considers to be dangerous. Now we'll look at sulfur dioxide. This is from CAMS for today. This is the global view for total column, and we can see it's still coming up in the Pacific here, and this looks like a new almost a new source here, but we'll look closer at that. Here it is at 500 HPA, so it's shooting up and gathering at 500 HPA. So we'll look a little closer at that area. Here's the East Tropic view. So here's China. We have higher readings here. This is from civilization. Here's India, that's from civilization. Here's Saudi Arabia, all that's from civilization. Here it is at 500 HPA, so it looks like here in the Pacific are two sources. Down here, this is near the Nishinoshima volcano. Then there's another one up here, east of the Kuril Islands, and you can see the shock waves coming out. So it equates to volcanic and earthquake activity and plate movement, sudden movements. Here's the Pacific view. Now the ring of fire for your earthquakes is all the way around here, all the way coming up. Here it is at 500 HPA, so I'm going to zoom in here. So here's this source with the volcano, but then this one is up here almost, well, like here's Kamchatka, Russia, here's the Kuril Islands, here's Japan, and it's a huge area that goes straight across. This could be from plate movement. We've had so much plate movement, and as it moves on one side, I'm thinking it moves on the other side, and we've been seeing a lot of sulfur dioxide on this East Pacific too. Not only from Popocatépetl, but I'm thinking from plate movement as well. Here's the Central America view. So here's Mexico. This is from Popocatépetl, and then it's streaming out and across, and this is either new or leftover. It's hard to tell. Now here it's more concentrated, so this could be a new release here in the Pacific with the plate movement. We're seeing also this is Colombia down here in South America. We're seeing a high release here. They have a lot of earthquakes there and down this western side. Another release here in Ecuador. That's probably earthquake related. Here's the North Pole view. Now we're seeing higher readings of sulfur dioxide moving across the Arctic, and this is not good news for the sea ice, because this sulfur dioxide is mixed up in whatever comes down on the ice, whether it's rain or snow. We have a lot of smoke moving across the Arctic that's getting mixed in as well. So it's not just regular rain and snow, it's toxic and acidified and ash-filled rain and snow that's coming down on the ice, so that's another reason that it's melting so fast. And here it is at 500 HPA, so we can see we have some higher readings even. It's going higher up in the atmosphere here in the Arctic region. Here's the South Pole view, so we can see that the greens are going all the way around, even down over this Ross Sea and coming down over the northern part of the Antarctic. And here it is at 500 HPA. Now, I took some earthquake pictures this morning. It's been really active. When I took these pictures, there were 277 worldwide, and we've had a lot of fives. There was a 5.1 in North Carolina this morning. That was the first thing I saw when I got up, and there was a 5 point something up here where we had that 7.8 near Alaska a couple of weeks ago. There was shortly after this 5.1 in North Carolina, there was a 5 point, I think this was a 1 or 2 here in the mid-Atlantic, right on this red line. Then we had a 5 point something down here just south of Africa, just shortly after this one, and that's right on this Antarctic plate line. And then these are 4s, lots of 4s as well. But those are the 5s, so that's the big news. Here in Southern California, in the Ridgecrest Searles Valley region, we had 21 here today, so that's still moving. In western Nevada, the Tonopah over to the Mammoth Lakes region, there were 67 here today. This is off the west coast of California. This is the San Andreas fault line where it comes up and meets with the Juan de Fuca plate, and then the Cascadia subduction zone is to the east of that. We've got activity right at this fulcrum point. There was a 3.8 and a 3.7. Those came in yesterday. The 3.8 came in at 5 o'clock yesterday, and then the 3.7 came in at 8:23 p.m. That's Pacific time. Here's that 5.1 that came in at Sparta, North Carolina. It came in at 5:07 this morning Pacific time, which would have been 8:07 Eastern time. It was very shallow. It was only 3.7 kilometers deep. So with it being shallow like that, it causes a lot more shaking, and people felt it hundreds of miles away, hundreds of miles. And damage. I saw pictures of cracked roads and like brick buildings, buckling and different things. So 5.1 is significant, especially if it's near a populated area. Now, Sparta, North Carolina is not a huge population, but it was only 4 kilometers from it. So it wasn't out in the middle of nowhere. And so here's another picture. This all started yesterday at 9:43 p.m. Pacific time. There was a 2.3. Then at 10:57 there was a 2.6. Then at 11:02 there was a 2.0. Then at 11:06 there was a 2.2. And then at 5:07 there was the 5.1. So here was the 5.1, but here are the others, and they've had some aftershocks since then. But you can see one of them happened right on the road. So it was between Sparta and Glade Valley, but the reporting station was Sparta. So this is almost on the border, the northern border of North Carolina and southern Virginia, and the western, it's almost to Tennessee on the west side. And Dallas had an earthquake. This was a 2.3. This came in last night at 11:33 p.m. 5.4 kilometers deep. But this is Dallas, Texas. We can see, they just say northern Texas, but it's in the Dallas region. Northwest Dallas region. So here's that 5.2 in the mid-Atlantic ridge. This came in at 5:42, so that was about half an hour after the 5.1 in North Carolina. So this is on that red line. So we're seeing plate movement here. And here's a picture of the 5.2, and then this 5.3 down here in Prince Edward Islands region. This came in at 9:30 this morning. So this is showing me that this plate is moving. This whole thing. Then this is just south of New Zealand. This is the Macquarie Island region. There were 2 right on top of each other, a 4.8 and a 4.7. This is south of Alaska. This is in the Aleutian Islands. Here's this 5.2 at Perryville. This is where they had the 7.8 a couple of weeks ago, and there was this is 4.5 over here, and then these are some 3s. So big activity up there. This 5.2 came in at 7:57 this morning, and those are all of those pictures. So lots of stuff. Now let's move on. We're going to look at sea ice next. So here's Climate Reanalyzer for sea ice and snow cover for today. And I'm going to blow this up. This is in concentration. We can see a hole opening up here on this northeast corner of Greenland. Heavy melting going on up here, and this Beaufort Sea is pretty much collapsing now after the cyclone, and there's some more systems moving through. They're not as powerful as that cyclone was, but you can see the darker area, that's where it's a lot less concentrated. And when we go to NASA Worldview and look at these areas, you'll see open water, a lot of open water in these areas between the big ice chunks. So let's just click back through the slideshow. Oh, we can also see open water all along this Alaska coast and this Canadian coast, so it's really melted. As this is thinning down, it's also melting in, and it's the outer edge is coming in as well. There's just a little skim of ice left here on this right side of Severnae Zemlya. We can see that the rest of, like, this whole Russia coastline is completely clear, and it's getting really thin on this eastern side of Greenland. Svalbard is clear, Franz Josef Land is clear, and Baffin Bay all the way up on this west side of Greenland is clear, and a bunch of these tributaries in the Canadian islands here, or archipelago, are getting clear. And there was an article that came out a couple of days ago about the Methane ice shelf collapsing up here on Ellesmere Island. I did a special broadcast. I shared that in my show yesterday, I think it was, for my Subscribe Star members on my daily update. So there's that. So we're going to click back through and see what's happened this week. So there's today. Here's where it was yesterday, and you might see some holes open up and close up, and the extent looks bigger one day than the other, and it doesn't mean it's refreezing. It just means that the way the ocean waves have moved and the wind has blown the ice, it's either blown it together or blown it apart or something. Here it is on the 7th. Here's the 6th, the 5th, the 4th, the 3rd, and here's last Sunday. So I'll click back through going forward. So you can see heavy melting here on Saturday and thinning out over that the Beaufort Sea, and then we can see it's like a hole is opening up here now. Here's the Navy model for the sea ice thickness for today, the night that was run on the 8th. Here's the color ledger on the right. The aqua is about 2 meters thick to 2.25. Bright aqua is 2.25 meters thick. This darker aqua is about 1.5 meters thick. The dark blue is about 1.25 meters thick. Then when it goes into dark purple, it's about 1 meter thick. The lavender is about half a meter thick, down to the white, which is 0 or just a skim, and then no color is no ice. So here's where it is today. So we can see these white areas opening up around this north coast of Greenland, and here around Alaska and Canada, and then quite thin down here in the Beaufort Sea. So there are holes in the ice there, and it's quite thin here. And I've named these quadrants 1, 2, 3, and 4. And so the North Pole did not go ice-free this week, as some people were thinking, but it's in the dark blue, which is about 1.25 meters thick. Melting is going on here in quadrant 3, coming up through from Greenland up, and you can see more of the dark blue now, and the aqua is becoming less, and it's still melting down. Now, sometimes we see a wider gap between the coastline and the sea ice than what we're seeing now, and it's like I said, it's not because it's refrozen, it's because the wind and the waves have blown the ice back together and made it more packed together. But we're not really seeing any thick sea ice like into the yellows and reds and greens now. Now we're down to aqua and under. So the thick sea ice is gone, it looks like. Here's the 30-day model, the animation. This is from the Navy, and this is the data that goes back for 3 weeks, and then they forecast out a week ahead. So the forecast ends on August the 16th, and it starts on July the 18th. So let's zoom in and watch this go. So we can see what's gone on for the last 3 weeks. And then the forecast out. So we're really seeing this aqua part just shrink down, and just really, it's weird to watch it. Okay, here's the end of the animation for August the 16th, which is next Sunday. Now this was run on August the 8th. That's what this number is. So this is what they're showing the model for right now as to what it will look like next Sunday, with this almost all of this eastern side of Greenland to be ice-free. Just a little skim of lavender, which is very thin here, and then a lot of this northern side of Greenland to be ice-free, and quite a gap between the coastline and the ice edge, so that's getting bigger. We're also seeing it thin way down. There's a hole opening up here next to the dark aqua, and here's Ellesmere Island, and we can see it melting all around the coastline there, and then around the rest of the coastline on this Canadian archipelago. And the Baffin Bay, we're going to see open water. We'll be seeing open water here. Not Baffin Bay, I'm sorry, the Beaufort Sea, and just quite thin. And when they talk about sea ice extent, they count every little crumb of whatever is sea ice. And you know, when people talk about the Blue Ocean event, I'm now going to refer to it as the Blue Ocean equivalent, because it's so hard to know when we're down to what the last what is it, 1,000 kilometers, square kilometers, or however many of sea ice we have. So what I'm going to refer to it as is a Blue Ocean equivalent, because when we have big gaping holes between the ice pieces, then the sunlight is going through and heating up the water. There's no reflectivity, and so you're going to get the effects of the water heating up and all those reinforcing feedback loops, as if it was all blue ocean. So for a lot of it. So I don't know if I'm explaining myself well. And that can cause a lot of problems with our climate. We were already seeing huge problems with the climate. The jet stream is all broken up, and the crops are a mess, and everything's a mess. So anyway, we're also seeing quite thin here around all these edges. So by the end of August, I'm thinking that this Beaufort will be open from where you see the dark purple over. This will all be open, and it'll be most of this area from here out will be open by the end of August. And we're still not through the melt season. The melt season goes, they say, traditionally till about September 20th, and but we've seen it melt into October. So, and as hot as this sea surface temperature is, it could keep melting into October. So all bets are off. We're in no man's land. With as high as the methane is, we just don't know what to expect. So we have to just keep watching it. And I'm not making huge predictions about Blue Ocean event. I'm just watching and reporting. So there's that. So those are all of my pictures there. Now let's move on to Climate Reanalyzer. This is the maximum temperature for today. We can see that most of the Arctic is green, in the green, which is above 0. We've got a little tiny line that's in the blue here, and a little speck over here on the left that's in the blue, which is about freezing. Here's the flat view, and I'm not going to go over a whole bunch of stuff that's not in the Arctic. I want to really focus on that. Here's the 2-meter temperature anomaly. This is the air temperature where it's warmer than normal. We can see browns going across most of the Arctic. The dark brown has moved down into Russia and down into Europe now, and over into northern Canada, and starting to move down through the US. So the northern hemisphere is up 0.8 C higher than normal, and the Arctic is up 0.9 C higher than normal. And then we see a lot of blues right next to the browns, so we have cooler than normal right next to the hotter than normal. Here's precipitation and clouds for today. We can see it's raining here in the Beaufort Sea. That will melt the sea ice very quickly, and it's also raining up here in the Chukchi Sea and here in the North Atlantic on the east side of Greenland, and then it's snowing further inland, and it's also raining on the southeast side of Greenland. So this will make the ice sheet melt even faster. Here's sea level pressure. We've got some highs set up across the Arctic. We've got a low pressure right here on the coast of Canada. It's not hugely low. And then a low pressure up here in the East Siberia Sea. It's not hugely low. I don't see it as very destructive, but any kind of wind or any kind of activity can do stuff to the sea ice. And it's raining. This is where that rain system is here. Here's the jet stream. Now it's hard to see here. I'm going to show you the jet stream on Earth Null School in a moment. But here it is on the flat view. It's a lot stronger in the southern hemisphere, but it's broken. It's not just doing loops like it used to. It's broken. And so that's why we're seeing weather chaos. Here's sea surface temperature anomaly. This is updated to yesterday, the 8th. And so here in the Arctic, we're seeing browns and reds and into the pink. So that's at least 2 to 6 degrees Celsius higher than normal. And it could be more than that. It could be above that. They're just registering up to 6 C higher than normal. So anywhere where there's no ice, it's all higher than normal. You can see that. Look at this Baffin Bay. Here, look at the Kara Sea, and here in the Laptev Sea, and all around. So I'm just holding my breath, waiting for the methane bomb to go off. I'm just holding my breath, just expecting to see that just any moment now. So the northern hemisphere is up 0.9 C higher than normal. The North Atlantic is up 1 C. The North Pacific is up 0.8 C. Overall worldwide we're up 0.5 C higher than normal. So almost all the oceans are, almost everywhere it's higher than normal. Now, but you've got some areas, look, around the equator where it's lower than normal. So, go figure. Doesn't make any sense to me. Here's Earth Null School now. we can see these highs and lows a little bit better here. Here's this system on northern Canada where it's raining. They're showing like 22 mile an hour wind. That's 24. That's pretty good wind for the Arctic. Up here in the East Siberia Sea, that's 20 mile an hour wind. So we've got that system up there. And but if we look at the sea level pressure, let's look at that. Like on this system, that's 1,004 millibars. So that's not a dangerous system with the pressure. 1,004 on that. Then down here above Canada, it's 994. So that's not real low. It is a low, but it's not super low. So here's 1,001. So you just have to kind of look at each one. Now let's look at the jet stream. Here it is. That's crazy. So here's North America, and see, we've got one coming down from down low coming up, and then here's the one from the Arctic that's split and coming down, and it only comes into the northern part of the US and then goes back up. But it's broken. It's just, and then where it breaks up, then it's got all these circular, sets up all these weird systems for the chaotic weather. Then you have hot air meeting cold air, and then you get chaotic weather and dangerous systems that happen. So here you go. So this is, here's India, China, Russia up here. Here's the Pacific. Now look at the southern hemisphere. That's crazy. You see that? So there you have it. Mother Earth is having a nervous breakdown. Alright. Now, National Snow and Ice Data Center. Here's sea ice concentration. This is as of yesterday. In the Arctic, we can see the dark blue is where it's less concentrated, and it's quite thin over there, and you can see this hole that's opened up on this northeast edge of Greenland. Here's the sea ice extent chart. Now, extent is different than thickness. We've talked about this. The dotted line is 2012. That was the lowest extent on record until this year. and then we went lower than that, and starting in June, well, it was lower than that earlier, May and June. Then it went a lot lower than that in July, and they're a little bit behind on charting everything, so it looks like at the end of towards the end of July it was just starting to cross and meet up with 2012 sea ice extent. But like I said, they count every little crumb as extent. Pond scum, I call it pond scum. Okay, here's the Greenland Ice Sheet today. Here's where the melting is. The salmon area. That's where the surface melt is happening. Of course, it's been raining there. These are the total days of melt this year. You can see around the edges, you can see much higher. And even into the interior it's been melting. Here's their chart, the melt extent for this year. The blue-green the dotted blue line is the median from 1981 to 2010. The red line is this year. So we can see it hop back up at the end of July. So we have massive melting going on. Now let's look at NASA Worldview. Let me refresh this. So almost all the data's in. We've got enough. So here's the sea ice concentration for right now. Here's Greenland. Here's the North Pole. We can see heavy melting over here on this northeast edge of Greenland and on this eastern side, and it's melting here just to the east of the North Pole. It's really starting to kick in. Then on this western side, this whole Beaufort Sea that's collapsing. You can see, and where you get into these different colors, that shows the degree of concentration. And when you get down into the purple, that's when we look at this without this layer, you'll see huge areas of open water. That's where it's less concentrated. The sea ice is not just one flat thing of ice, smooth. It's pieces of ice that are smashed together, basically, and then they freeze together. And so the areas around the pieces of ice melt first, and then that's where you see the concentration starting to get less and less, and then those big pieces start melting. So let's turn that layer off. Now we've got a lot of smoke coming in. Here's all this smoke from the wildfires, and that's getting mixed in the clouds. So remember we've got a system up here in the East Siberia Sea, and we've got a system here and down here where it's raining. So this system down here, this is rain. So let's start over here at northern Greenland. see what we can see. Now we're looking through some clouds. This is a hole. There's a hole in the sea ice there. And here's the coastline. We're looking through clouds here, but we can see the ice there. And it's sometimes the waves push it back up towards the coastline, and then as they go out it pulls it back out. So this is Ellesmere Island, and the ice shelf that fell apart this week is right here. You can see a big hole there. And I was confused when I was looking for this because I saw this line. I was thinking that this line, that was supposed to be landmass out there, but this is where the edge used to be, but it's not anymore. So that's the Methane, or was the Methane ice shelf. And you can see it's just all broken up there. But that happened on, I'll give you a quickie, a quick rundown on what happened on July 29th. This is what it looked like. So here's this ice shelf. It's still intact. Now you can see pieces, but it's still all intact there. And we got a bunch of clouds on the 30th, and then on the 31st you can see where it broke away. And that's what all the articles were talking about. So it's this big piece that broke away. Now we got a bunch of clouds, and here's the piece moving out. We can see that through the clouds on the 2nd. Here's the 3rd. Here's the 4th. Here's this piece. You can see it moving out. That's through clouds. Here's the 5th. You can see it here. Here's the 6th. Did you see the big jump there? Here's the big piece that was down here. Here's the 7th, and it's way up here. Let me zoom out a little. So here's the piece here that was down here. There's the 8th. Here it is, all the way up here. Yesterday, and then today, it's over here. And that was down here. And that was a huge deal. That was, there were lots of articles about that. People are in grief over seeing that ice shelf break off. And I didn't know until I saw the article, and I'm like, oh, well, we've been watching all this ice break up. I didn't realize that. So it's much worse. All of this is much worse than we thought it was. And if you haven't been really studying all this stuff, and I've been studying as best I can, but I don't know about every single ice shelf and what's going on, but it's all breaking up. And that's just one example. But this is a good view. There are no clouds in here, just a few clouds here and there. But you can really see the breakup here. So here's this system with the rain. So that could be really, really tearing up some more ice there. 20 mile an hour. That's good size. Even though it's not real low pressure, that's still strong enough. to be tearing it up. So let's just zoom in here in between the clouds and see. Now see the big open water? That's what I was saying about the concentration. And these pieces of ice are not real big. So that's going to go fast. Here's the 80-degree north latitude. Here's the ice edge here. You can see it right there. We got fire trucks in the background. Fire trucks and sirens. Let's zoom in here. There, you can see we're looking through a thin layer of clouds, but you can see a lot of open water there. Here is Reanalyzer. Here's this Vovolov ice cap. You can see it pouring into the ocean. It's still melting. This is all ice-free. Those are clouds that you're seeing. There's no ice over here. These are clouds. Here's the Russia coastline right there. We can't really see it because of the clouds. Here's Svalbard. It's cloud covered today, but there's no ice around there. That's kind of not much more we can see today. Here's this part just above Greenland that's going through heavy melting. You see there. And here we can see heavy melting. So that's open water between the big pieces of ice. So that's at 88 degrees north latitude. Here's the North Pole. So that's what it looks like today. So I'm going to turn that layer back on. Oh, I was going to also take you back through the week. So last Sunday was the 2nd. So here's where we were last Sunday with the melting or sea ice concentration. So I'm just going to click through. Here's Monday, the 3rd. Here's Tuesday. Wednesday. Now sometimes you have to refresh it to get all the quadrants in there. There it is. Heavy melting. Here's the 6th. And you start lots of melting on this east side. Here you can see this collapse going on in the Beaufort Sea. Here's the 7th. So that was Friday. You refresh that. See this hole here. here's yesterday, the 8th. And here it is today. So that's kind of where we're at with all of that. Now, this is turning into a long show. Let's see what else we need to look at on earthquakes. And we've got a bunch of 4s I didn't report on. We've got one up here in the Kuril Islands, one here. This is in the Northern Mariana Islands, 4.4. 4.5 Papua New Guinea. 4.6 Indonesia. 4.5 Indonesia. 4.9 Kamdo, China, that was a big one. 4.9 Iran. 4.2 Greece. Oh, look, here's a new one. 4.6 off the coast of Central America. We saw some sulfur dioxide next to that in Colombia. Look, that's right on the edge. This is the Cocos Plate. This one just came in. 4.5. This is in the armpit. I call it the armpit. From Alaska to Canada. McCarthy, Alaska. Oh, look at that depth. 0.1 kilometer depth. That was almost at the surface. Look, they've got a cluster. They've had 8 here today. 3.9. That came in at 10:19 last night. These are pretty shallow, but this last one is the most shallow. 4.5 at 0.1 kilometer depth. So that's not good. Magma's rising. So down here is that earthquake in North Carolina. So in the last 24 hours there have been 7. So since the 5.1 there was a 1.8 at 8:45 and a 1.7 at 8:58. These times are all Pacific time because that's my time zone. I've got it set up for that. So it's still rocking there. But this is on the edge of this North America craton, so this can be seismically active. What have we got down here? 3.1 Puerto Rico. So, I think that's all I wanted to go over on earthquakes and things. Now I'd like to end the show by reading the last chapter of Matthew. It's chapter 28. And this is after the crucifixion of Jesus. And this is his resurrection. In the end of the Sabbath, as it began to dawn toward the first day of the week, came Mary Magdalene and the other Mary to see the sepulchre. And behold, there was a great earthquake, for the angel of the Lord descended from heaven, and came and rolled back the stone from the door and sat upon it. His countenance was like lightning, and his raiment white as snow. And for fear of him the keepers did shake, and became as dead men. And the angel answered and said unto the women, Fear not ye, for I know that ye seek Jesus, which was crucified. He is not here, for he is risen, as he said. Come, see the place where the Lord lay, and go quickly and tell his disciples that he is risen from the dead, and behold, he goeth before you into Galilee. There shall ye see him. Lo, I have told you. And they departed quickly from the sepulchre with fear and great joy, and did run to bring his disciples word. And as they went to tell his disciples, behold, Jesus met them, saying, All hail! And they came and held him by the feet, and worshipped him. Then said Jesus unto them, Be not afraid. Go tell my brethren that they go into Galilee, and there shall they see me. Now when they were going, behold, some of the watch came into the city, and shewed unto the chief priests all the things that were done. And when they were assembled with the elders, and had taken counsel, they gave large money unto the soldiers, saying, Say ye, his disciples came by night, and stole him away while we slept. And if this come to the governor's ears, we will persuade him, and secure you. So they took the money, and did as they were taught. And this saying is commonly reported among the Jews until this day. Then the 11 disciples went away into Galilee, into a mountain where Jesus had appointed them. And when they saw him, they worshipped him, but some doubted. And Jesus came and spake unto them, saying, All power is given unto me in heaven and in earth. Go ye therefore, and teach all nations, baptizing them in the name of the Father, and of the Son, and of the Holy Ghost, teaching them to observe all things whatsoever I have commanded you. And lo, I am with you alway, even unto the end of the world. Amen. Matthew chapter 28. And then after his ascension, and he stayed with the disciples for 40 days, teaching them and getting them ready to go out into the world and, be disciples and do healings and preachings and teachings and gathering people. And anyway, I just think it's beautiful. I like it where he says, I'm with you till the end of the world. Or what do you say? Yeah, even unto the end of the world. So we want to remember this. And so these were supernatural things that God did with the earthquake and the angel and moving the stone back. And so a lot of the stuff that we're seeing with the earthquakes and different things, it's supernatural. And we can have faith in God for his supernatural protection and supernatural guidance, but we have to believe. And so that's what I think we need to do in these last few days and weeks and hours. And I do believe we are in the end times, and I've been called to, like a watchman on the wall, I've been called to show you where we are with the methane and the sea ice and the earthquakes and the climate, to show you how close we are. And every day, every week, every day, we're closer to the end than we were before. And so if you haven't given your life to Jesus Christ and repented and asked for forgiveness and then started living a godly life, it's not too late. Now is the time. Now is the time before his return. And I believe the end is near. So I'm praying for everyone I'm really praying for everyone. So, God bless you. Go in peace. And I will talk to you soon. And I'll love you all. Until next time. Good night.